Hi everyone, today we are going to talk about a very important topic, which is different stages of stars' life cycle. So the first thing here that we are going to talk about is that the 7 main stages of a star. Stars come in a variety of masses, and the mass determines how radiantly the star will shine and how it dies. Massive stars transform into supernovae, neutron stars, and black holes, while average stars like the Sun end life as a white dwarf surrounded by disappearing planetary nebula. All stars, irrespective of their size, follow the same 7-stage cycle. They start as a gas cloud and end as a star remnant. And the second thing here that we are going to talk about is that the first stage is giant gas cloud. A star originates from a large gas cloud, from a large cloud of gas or a gas cloud. The temperature in the cloud is low enough for the synthesis of molecules, and the Orion cloud complex in the Orion system is an example of a star in this stage of life. And here are some pictures that describes or shows you how does the giant gas cloud looks. And here we have the second stage, which is the protostar. When the gas particles in the molecular cloud run into each other, heat energy is produced. This results in the formation of a warm-up clump of molecules referred to as the protostar. The creation of protostars can be seen through infrared vision, as the protostars are warmer than the other materials in the molecular cloud. Several protostars can be formed in one cloud depending on the size of the molecular cloud. And the third stage here is the T-Tauri phase. T-Tauri stars begin when materials stop falling into protostar and release tremendous amounts of energy. The mean temperature of the Tauri star isn't enough to support nuclear fusion at its core. The T-Tauri stars lasts about 100 million years, following which it enters the most extended phase of development, the main sequence phase. And here is a picture that shows how the T-Tauri phase looks. Here we have the main sequence. The main sequence phase is the stage in development where the core temperature reaches the point for the fusion to commence. In this process, the protons of hydrogen are converted into atoms of helium. This reaction is exothermic. It gives off more heat than it requires, and so the core of a main sequence star releases a tremendous amount of energy. And here are 2 pictures that says how the main sequence looks. And we have the red giant. Red giant is a star converts hydrogen atoms into helium over its course of life as its core. Eventually, the hydrogen fuel runs out and the internal reaction stops. Without the reactions occurring at the core, a star contracts inward through gravity, causing it to expand. As it expands, the star first becomes a subgiant star and then a red giant. Red giants have cooler surfaces than the main sequence star, and because of this, they appear red than yellow. The fusion of heavier elements. This is the 6th stage. Helium molecules fuse at the core as the star expands. The energy of this reaction prevents the core from collapsing. The core shrinks and begins fusing carbon once the helium fusion ends. This process repeats until iron appears at the core. The iron fusion reaction absorbs energy, which causes the core to collapse. This implosion transforms massive stars into a supernova, while smaller stars like the Sun contract into white dwarfs. And finally, the last stage, which is supernova and planetary nebula. Most of the star material is blasted away into space, but the core implodes into a neutron star or singularity known as the black hole. Less massive stars don't explode, their cores contract instead into a tiny hot star known as the white dwarf, while the outer material drifts away. Stars tinier than the Sun don't have enough mass to burn with anything but a red glow during their main sequence. These red dwarfs are difficult to spot. These may be the most common stars that can burn for trillions of years. This is the last thing that we talked about. I hope you enjoyed the video and thank you for watching.